Good morning, friends. How are you today? Hope everyone had a good weekend. You've had some time to get outside and enjoy the sun while still socially distancing. Our lesson for today is going to be talking about exponent rules. So we're going to have this lesson today, and then we're going to have a lot of practice this week. Please make sure that you're checking out that weekly agenda that I'm posting on Monday morning of every week. It's going to give you what we're doing for the week so you can look ahead and see. And especially like this week, we have a lot of IXL, so you can pace that out and maybe even work on some of it that maybe isn't coming up until Tuesday or Wednesday if you have extra time. Also, within each of those, I have some time limits on there about how long it should take you. You shouldn't be spending any more than about 25 minutes on math each day. And so if you have more time and you want to, that's fine, but that's what's required. So just keep that in mind. So for our warm-up today, I chose one of the questions from the quiz we had on Friday, and this one was the most frequently missed question. It says, give the next three terms in the sequence. So maybe you got it right and you did fine. Maybe you didn't do so well with it. Try it anyway. So pause the video. Make sure you've got your notebook ready, your pencil, your calculator, and go ahead and give this one a go. When you think you've got the solution for the next three terms, unpause the video. And we're going to go ahead and talk about what this looks like for the next three terms. So when I look at going from 81 to negative 27, negative 27 to 9, what I notice, the first thing is I'm going from positive to negative, negative to positive, positive to negative. So my sign for my number is changing to its opposite. And so that means that I'm either having to multiply or divide by a negative each time. When I take my calculator and if I do 81 divided by negative 27, I get negative 3. So that means that I could be dividing by negative 3. But I know when I'm talking about geometric sequences, it says it's the change in multiplication. And so another way to look at that would be multiplying by negative 1/3. And that will give me the same answer each time, and it will actually help me later on down here. So if I do negative 27 times negative 1/3, that will give me positive 9. If I do positive 9 times negative 1/3, that would give me negative 9 over 3 or negative 3. Now for my next ones, so if I do negative 3 times negative 1/3, so a negative times a negative is a positive. You can put that negative 3 over 1 if you want. And those 3's reduce each other, and so that gives me just a 1 for that one. So my next term is 1. So now I'm going to come over here. I need a little bit more space. 1 times, remember that common multiplier was negative 1/3. Well, any number times 1 is just itself, so my next one is negative 1/3. And then for my third term, I'm almost done. So for my third term, I'm going to take negative 1/3, and I'm going to multiply it by, again, by that common multiplier, negative 1/3. A negative times a negative gives me a positive, and multiplying straight across, I get 1/9. So my last term is 1/9. So for this question, giving those last three terms would be positive 1, negative 1/3, positive 1/9. So this week, we are going to be learning about some exponent rules. And so we've got 5 rules that we're going to cover today. And all week long, you're going to have some practice with all 5 of these rules. So let's get started. At the top of your paper, I want you to write down the title for this, product rule. You could write down exponent rules too if you wanted. Write down product rule. And product, we know is when we're talking about multiplication. So the product rule, it's telling me when multiplying with the same base, remember the base is like the x here, the 7 here. So those bases have to be the same. We keep that same base and we just add the exponents together. So here's our example. x to the third times x squared. The bases are the same, but my exponents aren't, and so I need to add those together. Copy this problem down. You're going to do this with me. So one way to look at this is writing out x to the third is x times x times x. Times, and then x squared is times x times x. So thinking about how many x's did we put down there? 5 in all. Or we could just add the 3 and the 2 together with the exponents. So the answer is x to the fifth. Now looking at 7 to the fourth times 7, what would be the exponent on that 7? That would just be a 1. So it just tells us how many 7s we have there. And so if we were going to expand this, 7 to the fourth would be 1, 2, 3, 4 7s multiplied, and then we put one more for the other 7, so 7 to the fifth power. Remember that the rule with this is that the bases have to be the same, the x and the x, or the 7 and the 7. Those must be the same. The next thing I want you to write down on your paper is quotient rule. Quotient is when we're talking about dividing. So you can see all of our examples that we're going to do over here are all dividing. When dividing exponents, and think about it, when we multiplied, we added the exponents together. Again, you have to have that same base. That's key. But when we're dividing, you subtract the exponents and you keep the bases the same. So let's see what this looks like. Copy down the first problem, a to the fifth divided by a to the second. If at any time you need a little bit more time to write things down, just pause the video, write down, and then resume. So looking at my numerator, I'm going to have 5 a's. My denominator, I have 2. That's what the exponent tells me. And then what I can do is start crossing those off. If it's the same on the top and the bottom, then I can eliminate those. So those 2 a's eliminate each other. These 2 a's eliminate each other, and I'm left with 3. So a to the third power is what I have remaining. I could also get that 3, that third power, by doing 5 minus 2. Let's look at our second problem, b to the fifth divided by b to the fifth. Well, we know anything divided by itself is 1, right? But let's prove it. So in our numerator, we have 5 b's. In our denominator, we have 5 b's. And if I want to start eliminating those b's that have a pair from numerator to denominator, and that means that I end up with 1, not 0, because I'm not doing anything by 0. That just means I have b to the 0 power, but that means my answer is actually 1. We'll talk about that in a little bit. Let's look at our third example, 8 to the third over 8 to the second. Try to think about with this one how you would subtract the exponents. Think about what you would get, but let's expand it just to check. So we have 3 8s in the numerator, 2 8s in the denominator. Let's mark off. Let's reduce this way. Those 2 8s. Those 2 8s, and we have 1 8 left. So if we subtracted, we would have 8 to the first power, or just 8. Now let's look at this one. We have 2 c's on top and 4 c's on the bottom. So we're going to have 2 c's in our numerator, 4 c's in the denominator. And when we start reducing them, marking them from top to bottom, we end up with no c's left in the top. That means a 1 in the numerator, but we still have c squared in the denominator. So our answer would be 1 over c squared. Our next rule is power rule. Write that down on your paper. This is when we raise a power to a power. So you can see like we have a to the third to the second power, 2 to the fourth to the second power. We multiply these exponents. This is similar to the distributive property. So copy this first problem down. Again, pause it where you need to, and then pick back up with us. And looking at this first problem, a to the third to the second, this 2 exponent tells us that I'm going to have 2 a to the thirds. Not 2 times a to the third, but a to the third times a to the third. So it looks like that. And then if I were to expand that, I would have 3 a's for the first one and 3 a's for the second. So 6 a's altogether. And so you get a to the sixth. You can also see this by 3 times 2 is 6. So that's what our rule tells us, that we are just multiplying those exponents. Let's look at 2 to the fourth to the second power. This exponent tells us how many 2 to the fourths we have. So we have 2 to the fourths. If we expand it, that's 8 2's altogether. So 2 to the eighth, which is 256. Our third example, notice that this has 5x squared in parentheses, and then it's raised to the third power. So that means that we have 3 5x squareds, just like that. So then you will combine your like terms, 5 times 5 times 5, which gives you 5 to the third power. And then x squared times x squared times x squared, which is x to the sixth, you get 125 x to the sixth. So again, looking at this is where it's like the distributive property. It's 5 to the third power and x squared to the third power. Similarly for xy in parentheses to the eighth power, that x and y are both being taken to the eighth power. So that looks like xy times xy times xy 8 times. So you end up with x to the eighth power, y to the eighth power. For our next rule, write down negative exponent rule. That just means that your exponent has a negative on it. The rule for this is you rewrite this as a reciprocal. Reciprocal, remember, means that we are flipping our fraction. So you rewrite this as a reciprocal, and the exponent turns positive. The terms with negative exponents in the numerator make a decimal. So if you have these terms with negative exponents in the top, when you're done with it, it would make a decimal. So let's look at this first example, x to the negative 2. That's like having x to the negative 2 over 1. And so now you flip that to make a reciprocal. So it's just 1 over x squared. Y to the negative 5, that would be like y to the negative 5 over 1. Rewrite that as its reciprocal, and you get 1 over y to the fifth. 12 to the negative eighth power is just going to be 1 over 12 to the eighth. Notice that those exponents all become positive now. Now, what about this one? You have 1 over a to the negative third. Remember, it didn't just say put it in the denominator, it said flip it. So if I flip this, that means that a to the negative third now comes up here, and that 1 goes in the denominator. And so you end up with a to the positive 3. That could be over 1, but you don't have to write that over 1. It's just a to the third. Our last power rule, or last exponent rule, is the 0 power rule. And this tells us that any number raised to the 0 power is 1. So remember back when we had b to the fifth over b to the fifth, we got b to the 0. And we said that was the same thing as 1, right? X to the 0 power is 1. 3 to the 0 power is 1. X, y, both of them to the 0 power, that means it's x to the 0 power, y to the 0 power. 1 times 1 is 1. So now I have a couple of problems for us to try to practice. So you'll need to pause the video and copy down the problems and then work out what you know. When you're done, unpause the video to check your work with the solutions. So for this first problem, we're going to combine our like terms, the 7 and the 5, which is 35. We're going to do the x's together, x to the third and x, and y squared and y to the ninth. So we have 7 times 5 times x to the third times x times y squared times y to the ninth. 35, because this is all multiplying, those same bases, we just add their exponents. X to the fourth, remember this x where it's just an x, that's like having a 1 there. And then y to the 11th, 2 plus 9. For the second problem, these all have the same base of a, so you do 10 plus 2, and that's in your numerator. And then that last one is a to the negative 6, so that goes in the denominator. It makes that a to the 6th power. Then you end up with a to the 12th over a to the 6th, and now you subtract, and you get a to the 6th power. Now you could have also done in another way. Let's do a different color. You could have done a, and then your exponent would have been 10 plus 2 plus negative 6. So that would be 12 plus negative 6, which would then give you the same answer, a to the 6th power. So either way, either of those solutions would be fine. These are our last practice problems that we're going to do in notes today. So pause the video to copy down the problems and try each one. And when you are finished working them out, then unpause the video to check your solutions. For the first one, we have all the same bases of x, so you're just adding your exponents together. So 6 plus 10 plus 1, and that will give you x to the 17th power. We're going to go down the column. The second one is power to a power, so that means you multiply those. So 9 times 6 is 54. Use your calculator if you need to. Don't get it wrong because you multiplied incorrectly. Negative exponent means we flip it or write it as its reciprocal, so that means 1 over x to the 7th. In this last problem in this column, it's 5 to the 2nd times 5 to the 2nd, same base, so that gives us 5 to the 4th over 5 to the 3rd. Then you subtract those exponents and you just get 5. Let's go to our second column. X to the 12th over x to the 1st, subtract the exponents and you get x to the 11th. In our second problem in this column, remember that that exponent is handed out to every term in those parentheses. So you end up with a to the 5th, b to the 5th, c to the 5th. In our next problem, we all have the same base of 3, and so you just add your exponents of 4, 1, and 8. So 3 to the 13th power. And then our last problem, these are powers to power. So 3 to the, or x to the 3rd is x to the 9th. X to the 4th to the 5th is x to the 20th. And now you have common base. You're multiplying, which means you add your exponents, so x to the 29th power. So that was a whole lot of information for today. You are going to do one section of IXL for practice today. Please check that in our weekly agenda. Make sure that you're checking on that weekly agenda. And for all of IXL today, you are under Math 8 or 8th grade math, not Algebra 1. So make sure you're in the right tab, you're doing the right section. You do not get credit for doing something that wasn't assigned. You're only getting credit for the things that I have assigned. If you are having questions about the lesson, our first Zoom chat this week is Wednesday morning from 9:30 to 10. Please come to that to ask questions. I can show you how to do problems through a doc cam. It's much easier to explain that way than trying to explain either via text or email. So if you have questions, please come to that Zoom on Wednesday. We will have a quiz on this on Friday. So lots and lots of practice opportunities this week. I hope everybody is doing well, and I really miss seeing you all. Have a great week.